Hello, welcome to IT Expert YouTube video series. Today we are going to talk about infrastructure security. What are Marco layers? Infrastructure security is the foundation for operating securely in the cloud. Infrastructure is the glue of computers and networks that we build everything on top of. For the purposes of this guidance, we start with compute and networking security, which also encompass workload and hybrid cloud. Although storage security is also core to infrastructure, it is covered in full depth in Domain 11 Data Security and Encryption. This domain also includes the fundamentals for private cloud computing. It does not include all the components of traditional data center security that are already well covered by existing standards and guidance. Infrastructure security encompasses the lowest layers of security, from physical facilities through the consumer's configuration and implementation of infrastructure components. These are the fundamental components that everything else in the cloud is built from, including compute, networking, and storage security. In cloud computing there are two macro layers to infrastructure. The fundamental resources pooled together to create a cloud. This is the raw, physical and logical compute processors, memory, etc., networks, and storage used to build the clouds. Resource pools. For example, this includes the security of the networking hardware and software used to create the network resource pool. The virtual abstracted infrastructure managed by a cloud user. That is the compute, network, and storage assets that they use from the resource pools. For example, the security of the virtual network, as defined and managed by the cloud user. The information and advice in this domain primarily focuses on the second macro layer. Infrastructure security for the cloud user. Infrastructure security that is more fundamental for cloud providers, including those who manage private clouds, is well aligned with existing security standards for data centers. Entire stack. Infostructure. Focus on storage, keep backup snapshots. Metastructure or management plane. Focus on management, IAM identity access management and SDN software-defined network. Infrastructure. Focus on core configuration and create entire stack from bottom up. Applistructure. Focus on application resilience and availability. What is management plane? Management plane is a single point of entry to the cloud network. Management plane can be accessed via REST API. Management plane must be controlled from hackers. Management plane access must be protected by MFA multi-factor authentication. All cloud resources can be provisioned, configured and accessed via management plane only. Management plane leverage data plane worker node to fulfill client requests. The management plane is the single most significant security difference between traditional infrastructure and cloud computing. This is not all of the metastructure but is the interface to connect with the metastructure and configure much of the cloud. We always have a management plane, the tools and interfaces we use to manage our infrastructure, platforms, and applications, but cloud abstracts and centralizes administrative management of resources. Instead of controlling a data center configuration with boxes and wires, it is now controlled with API calls and web consoles. Management plane security when building providing a cloud service. Delving into implementation specifics is beyond the scope of this guidance, but at a high level there are 5 major facets to building and managing a secure management plane. Perimeter security. Protecting from attacks against the management plane's components itself, such as the web and API servers. It includes both lower-level network defenses as well as higher-level defenses against application attacks. Customer authentication. Providing secure mechanisms for customers to authenticate to the management plane. This should use existing standards like OAuth or HTTP request signing that are cryptographically valid and well documented. Customer authentication should support MFA as an option or requirement. Internal authentication and credential passing. The mechanisms your own employees use to connect with the non-customer facing portions of the management plane. It also includes any translation between the customer's authentication and any internal API requests. Cloud providers should always mandate MFA for cloud management authentication. Authorization and entitlements. The entitlements available to customers and the entitlements for internal administrators. Granular entitlements better enable customers to securely manage their own users and administrators. Internally, granular entitlements reduce the impact of administrators' accounts being compromised or employee abuse. Logging, monitoring, and alerting. Robust logging and monitoring of administrative is essential for effective security and compliance. This applies both to what the customer does in their account, and to what employees do in their day-to-day management of the service. Alerting of unusual events is an important security control to ensure that monitoring is actionable and not merely something you look at after the fact. Cloud customers should ideally be able to access logs of their own activity in the platform via API or other mechanisms in order to integrate with their own security logging systems. How IaaS layer works. Client application sends request to management plane as REST request. Management plane creates sub-requests to compute controller to create VMs compute, storage controller to create storage virtual hard drive, and then link all the resources together and provide resource details to client as a response. What is BC business continuity and disaster recovery? Business continuity and disaster recovery is just as important in cloud computing as it is for any other technology. Aside from the differences resulting from the potential involvement of a third-party provider, there are additional considerations due to the inherent differences when using shared resources. The three main aspects of BC or DR in the cloud are ensuring continuity and recovery within a given cloud provider. These are the tools and techniques to best architect your cloud deployment to keep things running if either what you deploy breaks, or a portion of the cloud provider breaks. Preparing for and managing cloud provider outages. This extends from the more constrained problems that you can architect around within a provider to the wider outages that take down all or some of the provider in a way that exceeds the capabilities of inherent DR controls. Considering options for portability, in case you need to migrate providers or platforms. This could be due to anything from desiring a different feature set to the complete loss of the provider if, for example, they go out of business or you have a legal dispute. What is the data plane? In networking, the words plane, data plane, and control plane are frequently used to describe network topology. In this context, a plane is an abstract representation of where certain operations take place within the network. You can think of it as referring to the plane of existence of those operations. Any system that performs data traffic routing or filtering has a control plane and a data plane. A data plane has a managing control plane that's responsible for holding configurations, provisioning users, and deciding where operations reside. The control plane also holds the logic used by the data plane. The data plane is often used in diagrams that visualize network traffic, such as in the following example. What does the data plane do? While the control plane does the management and decision-making of network routing, the data plane does the work of forwarding data packets to their destinations. The data plane is a worker that sends data packets through routers, but the routing decisions are made by the control plane manager. For this reason, the data plane is often referred to as the forwarding plane, but it can also be known as the user or carrier plane. Data plane functions. Use routing logic from in the control plane. Use routing and forwarding tables. Send data packets to network interfaces. The data plane is responsible for processing communications from the control plane. Moving data packets from one location to another. How does the data plane work? A data plane's functions use routing logic from in the control plane, along with routing and forwarding tables to send onward data packets to network interfaces. The data plane is responsible for processing communications from the control plane and moving data from one location to another. How to secure cloud infrastructure. Picking the right cloud service provider. Understanding the shared responsibility model. Implementing identity and access management. Encrypting data. Protecting user endpoints. Upskilling all employees. Maintaining logs and monitoring. Harden hosts. Harden infrastructure services. Secure networks. Secure architecture. Harden management plane. What is SDN, software-defined network? Software-defined networking is an approach to networking that uses software-based controllers or application programming interfaces to communicate with underlying hardware infrastructure and direct traffic on a network. This model differs from that of traditional networks, which use dedicated hardware devices, i.e., routers and switches to control network traffic. SDN can create and control a virtual network or control a traditional hardware via software. Why software-defined networking is important? SDN represents a substantial step forward from traditional networking, in that it enables the following. Increased control with greater speed and flexibility. Instead of manually programming multiple vendor-specific hardware devices, developers can control the flow of traffic over a network simply by programming an open standard software-based controller. Networking administrators also have more flexibility in choosing networking equipment, since they can choose a single protocol to communicate with any number of hardware devices through a central controller. Customizable network infrastructure. With a software-defined network, administrators can configure network services and allocate virtual resources to change the network infrastructure in real time through one centralized location. This allows network administrators to optimize the flow of data through the network and prioritize applications that require more availability. Robust security. A software-defined network delivers visibility into the entire network, providing a more holistic view of security threats. With the proliferation of smart devices that connect to the internet, SDN offers clear advantages over traditional networking. Operators can create separate zones for devices that require different levels of security, or immediately quarantine compromised devices so that they cannot infect the rest of the network. Benefits of software-defined networking. Many of today's services and applications, especially when they involve the cloud, could not function without SDN. SDN allows data to move easily between distributed locations, which is critical for cloud applications. Additionally, SDN supports moving workloads around a network quickly. For instance, dividing a virtual network into sections, using a technique called network functions virtualization, allows telecommunications providers to move customer services to less expensive servers or even to the customer's own servers. Service providers can use a virtual network infrastructure to shift workloads from private to public cloud infrastructures as necessary, and to make new customer services available instantly. SDN also makes it easier for any network to flex and scale as network administrators add or remove virtual machines, whether those machines are on premises or in the cloud. Finally, because of the speed and flexibility offered by SDN, it is able to support emerging trends and technologies such as edge computing and the Internet of Things, which require transferring data quickly and easily between remote sites. What is Bastion Network? A Bastion host is a specialized computer that is deliberately exposed on a public network. From a secured network perspective, it is the only node exposed to the outside world and is therefore very prone to attack. It is placed outside the firewall in single firewall systems, or, if a system has two firewalls, it is often placed between the two firewalls or on the public side of a demilitarized zone. The Bastion host processes and filters all incoming traffic and prevents malicious traffic from entering the network, acting much like a gateway. The most common examples of Bastion hosts are mail, domain name system, web and file transfer protocol servers. Firewalls and routers can also become Bastion hosts. What is software-defined perimeter? A software-defined perimeter is a way to hide internet-connected infrastructure servers, routers, etc. so that external parties and attackers cannot see it, whether it is hosted on-premise or in the cloud. The goal of the SDP approach is to base the network perimeter on software instead of hardware. A company that uses an SDP is essentially draping a cloak of invisibility over their servers and other infrastructure so that no one can see it from the outside. However, authorized users can still access the infrastructure. A software-defined perimeter forms a virtual boundary around company assets at the network layer, not the application layer. This separates it from other access-based controls that restrict user privileges but allow wide network access. Another key difference is that an SDP authenticates devices as well as user identity. The Cloud Security Alliance first developed the SDP concept. Security shared model, provider versus consumer. Security of the cloud is cloud provider responsibility. Security in the cloud is consumer responsibility. What is workloads for cloud? A cloud workload is a specific application, service, capability or a specific amount of work that can be run on a cloud resource. Virtual machines, databases, containers, Hadoop nodes and applications are all considered cloud workloads. What are the challenges of managing cloud workloads? As cloud services mature, enterprises have adopted multiple cloud solutions to address the needs of specific workloads. Certain cloud resources are able to handle specific cloud workloads more effectively, improving performance and reducing costs. However, the task of managing a variety of cloud platforms can be quite cumbersome and time-consuming, adding significant cost and complexity. Hybrid cloud solutions like Dell Technologies Cloud can help by providing a technology with a common set of tools and consistent operations and infrastructure that dramatically simplify the task of managing multiple cloud resources. What is immutable workloads? With the rise of cloud services, immutable model infrastructure has come into prominence. The concept refers to servers or VMs that are never amended after deployment. In the immutable environment model, the servers work differently. Servers are never modified after they are deployed. If something needs updating, the new server is built from an image with the appropriate changes replacing the old one. Immutable infrastructure model. Steps you take when servers that are never changed after deployment but need updating. Validate the server. Build a new server from the standard image, with changes and packages. Facilitate the new server to replace the existing one. Decommission the existing or old server. Every server update is exact, timestamped, and redeployed. The old servers are still available for rolling back your environment. With this change, you almost remove troubleshooting for broken instances. Moreover, thanks to the OS-level virtualization and computing, the new servers are swift in deploying. This concept helps to speed up deployment. But is the actual performance augmented? Actually, yes. Performance in this infrastructure can occasionally be slower than the mutable infrastructure. However, the chances are very rare. What is important is horizontal scaling becomes easier, supporting rapid environment building with faster deployments and more VM machines. First, create OS operating system layer. Then apply patches plus configuration. After, add application layer changes. Build an image. Deploy image in test environment. Run security tests. If all tests pass, then label the build as a gold master build. Then perform functional testing. If all tests pass, then deploy to prod environment. Else restart the entire process. What is immutable deployment pipelines? Let's say we have an application that we want to deploy into AWS. If you are on the algorithms team at Stitch Fix, this is most likely a Python Flask application, with Unicorn for multiprocessing, and fronted by Nginx web server. Step 1: Building the RPM. First step would be to package our code into an RPM. To build an RPM, we first need to create a spec file. This basically dictates how to build the RPM, how to package the code, what dependencies to include, which scripts to put where, and what to run post-install. Let's look at some of these sections, called directives, in detail. %build. This is the step where you would compile code. Since we write Python apps, we skip this step. %pre. Anything to be done before installing goes here, creating users as an example. %install. Think of this step as moving files around into the right places. It is all about moving files from different sources into the build root directory, the root for building and installing your package. %files. Here you specify which files to include in the binary RPM. Usually you would have your application code, Nginx configs, and startup scripts all included. %post. This is the most important directive for us, as this is what pip installs the package and registers the startup scripts with config so that they may start on boot up. %postdone. This directive runs after you do yum remove package. It is essentially extra cleanup. After creating a spec file, we build it. You need to install RPM build package before you can build RPMs. Yum install RPM build. RPM build ba options hello world.spec. And voila, you have hello world.rpm file. This would then be pushed to some RPM repository so that it can be accessed in the future. The baking machine will need to have access to this repo to be able to pull in dependencies. Step 2: Baking the AMI. Now that you have created your RPM, it is time to create the AMI. To reiterate, the resulting AMI would just be a base AMI that has our RPM installed on it. Nothing else. Do avoid putting in unnecessary dependencies into RPMs that do not need them, as the more there are, the more need to be installed, the longer the bake stage will take. You could manually do this process by launching a new EC2 instance from a fresh base Amazon Linux AMI, configuring yum repos to point to your RPM repo, then installing your RPM on it, and taking an image. Thankfully, Netflix has created an automated tool for doing this, called Aminator. Emanator first creates an EBS volume from the snapshot of the base AMI and mounts it onto the machine it is being executed on. This is great because we don't TMT need to launch EC2 instances just to install our RPMs on them, we can do it right on the same machine. After mounting the volume, Emanator cruits into it to provision the system with our RPM. After provisioning, Emanator detaches the volume, makes a snapshot of it, and turns it into an AMI. This is a very easy step in the process. All we need to do is make sure that Emanator is installed on the machine that does the baking, and that yum repos are configured to see our RPM repo. Step 3. Deploying into AWS. Now that we have our AMI ready to go, we need to do a one-time setup on AWS for our application. This consists of creating an elastic load balancer and a Route 53 DNS entry pointing to the ELB. When we launch our application, we want to get to it by putting something legible into the URL, not something monstrous like this. Instead, we would create a new private CNAME entry, hello-world.internalstitchfixdomain.com, and point it to the load balancer's private IP. You can think of these steps as the scaffolding for the application one-time setup to create your application on AWS. For this scaffolding and deployment, we wrote an in-house service called Book of Magic to handle resources on AWS. To create our application, we run. This creates our internal ELB, and adds an internal CNAME DNS entry on Route 53 pointing directly to the ELB. Notice how for the scaffolding, we need to pass in the ELB health check endpoint and port. This is the endpoint that the ELB will ping periodically to check if the instance is healthy and should be attached to the ELB. The environment is important, as every environment will have its own ELB and Route 53 entry for isolation. Voila, the application scaffolding has been created and we are ready to begin a first deploy of the app. What this does is it creates a launch configuration with the AMI that we created our immutable server and sets the instance type. Then, an ASG is created from this launch configuration, specifying the min and max number of instances to have. By default we want at least 2 instances to always be up. This ensures that if one instance goes offline for any reason, the other will still be able to serve traffic while the ASG launches another instance up. Note how easy and interchangeable these instances are because they are configured to launch an EC2 instance from an image the AMI that we made with our RPM installed on it. Once all the instances are launched in the ASG and the health check endpoint has been verified to return 200, the ASG gets attached to the ELB. This means that we can now go to hello-world.internalstitchfixdomain.com and see our application. Thank you for watching this video. We provide hands-on training with labs, homework, group projects. Prepare you for the certification. Provide real projects. Internship opportunities. Support you in Resume, LinkedIn. Staffing support. Provide tech references. In-person, online class. Class retake options and more. Call us at 847-350-9034 for your free career consultation meeting. Please do not forget to like, share, and subscribe to our channel for the latest videos.